So hi everyone, thank you for staying so late in this day. Some of you may be expecting Mati Siman to give this talk. It was kind of a last minute change, but it's the same talk, so you're in the right room, although it's a different speaker. So today we're going to talk about serverless infections. I'm the head of AppSec research in Checkmarx. I've been there for the last 4 years. These are probably the best ways to contact me if needed. And if you have questions or anything else that you'd like, I'll be happy to answer. Also, this is usually the place where people need to justify what gives them the right to stand here and give you the talk. So my justification is that I see a lot of errors being developed in the industry by developers. And now when serverless is getting more and more, let's say, out there, the mistakes also, we see them more often than we used to. The problem is that a lot of people think that serverless gives them, let's say, the right to write vulnerable code, and it makes it immune to usual attacks. So this is kind of trying to show differently. So let's start. The agenda here is to give a quick intro to serverless architecture. I'm hoping some of you already know what it is. We'll talk specifically about Amazon's AWS Lambda. We'll discuss a few demos that we made, POCs, that actually managed to show that from a simple code injection, we managed to create a viral infection. We'll talk more about the security aspects of the Lambdas and hopefully get to the key takeaways in the end. So let's start with some legal stuff. I understand that, well, in the last couple of months or year, it is illegal to talk about cloud and about serverless technologies without showing this picture. So here it is. It's very important that everyone acknowledge that they saw it. Now we can put it behind us and continue. So what is this serverless thing? Let's talk in terms of evolution. Not that long ago, this is at least what I'm telling myself, we had hardware as a unit. If we wanted to scale up, we had to bring more hardware, more servers, put them in actual rooms. We call them data centers. This was back then in the past, and we had to make sure everything is taken care of, hosting, environment, etc. After that came the infrastructure as a service, when we didn't really had to buy hardware anymore. A good example is Amazon AWS, for example. The operating system was the unit of scale. If I wanted something, just bring another OS. So it abstracted the hardware. The next phase in the evolution was the platform as a service, where the application was the unit of scale. If you want an example, Salesforce have Heroku. I don't know if people know it, but it's a very good example of that. Also, you don't need to know what the OS is. You don't even care. You just deploy your application and you run. And now it's the age of serverless. Serverless means that we're doing function as a service. The function is the unit. You don't care at all about the, of course, the hardware, the OS. You sometimes don't even care about the language it runs on. So it's all about the functions. And a nicer way to show it, or a different direction, is talking about the time and timelines. So while we had data centers, it took months to deploy new servers, and the application lived years on them. It slowly minimized during the virtualized and cloud revolution, and then the container deployment. It got down to deployment by the second. Sometimes application ran for couple of seconds, sometimes hours, but not needed more than that. And now, in the last stage of the evolution, with serverless, we just deploy in milliseconds. We have not applications, but actual functions that live for between milliseconds and seconds, and this is all we need. The magic looks like this. All you need to do is to develop a function. You don't care about anything else. You push it or deploy it to the cloud, waiting for a trigger of some sort. We'll talk about these triggers in a second. When the trigger comes, the function is doing what it's supposed to do, and then it vanishes. It cleans, it dies, and that's it. No persistency, nothing stays after that. So the benefits, other than being able to say that you're using serverless, which is a great buzzword, you can say you're scalable. That's also a buzzword, so you have to. But it really is scalable. I mean, you have your functions on the cloud, and then from that second, you don't even care if you need to run and trigger the function, let's say once a day or thousands of times a second. It's the same. It's transparent for you. You just run it. The scalability is obviously a very good plus for that. No ops. You don't care anymore, as we said before. Hardware, memory, hard drives, patches, updates, all these operations. This really lowers all the headaches of the operations. And low cost. I don't really have the numbers to back that up, but I hear it from all around the industry. People are saying that the model of paying for only what you're using and being able to throttle your use for downtimes instead of really busy times, they really manage to lower their costs, some of them significantly. So this is definitely a benefit. Why then people don't, all of them, why not all companies move to serverless? Obviously there are downsides. One of the big downsides is it's a new paradigm. It starts from developers that need to actually learn how to code differently. It goes through the designers and architects that need to actually think about new ways, new structures of using their code, and organizations that sometimes are a bit, let's say, have problems adopting new ways. Also, it is a bit slower. Instead of running something local, as we know, you will need to deploy, copy, run it on a container somewhere. What the clouds usually do is, if there is a function that is used constantly, it is being cached, but still, there always is some sort of an overhead for this. There is problem monitoring. When you have everything running on one server, it's really easy to monitor everything. But now, when you have a function as a service, you don't even know where it runs. I'm not even talking about servers. You have absolutely no idea. Companies are trying to start thinking about how to cope with it. But it's supposed to be a big downside, especially for management. And the last thing that people say that makes them not go serverless is the platform dependent. There is no unity. So if you actually start deploying on Amazon, you'll have really hard time moving to other platforms by Google or Microsoft or anything else. So if we mention the companies, probably most of you know all the commercial solutions. There is the Google Cloud Platform and Amazon AWS Lambda. Microsoft have their own, and also IBM. There are also a bunch of open source solutions. Everyone has their own pros and cons. But this technology of function as a service is probably here to stay for a while because a lot of companies really put a lot of effort to make it work seamlessly. Okay, so we wanted to start and do some hacking and check how safe are these platforms. We made this small comparison and decided to go with AWS Lambda. It seems the most common and mature. They had an interesting wide language coverage, and this is where we put most of our effort in the demo. So let's discuss that in a nutshell. So the AWS Lambda Functions service, it was introduced in 2014. They support a lot of languages, Node.js, Python, Java. We got very excited because they added Go in the beginning of the year, which is nice. .NET Core, everything runs on Linux containers, and everything is fun. So if you want to trigger a function on the AWS Lambda service, there are two ways to do that. One way is the explicit one, just to use the REST API to call a Lambda function. And the other one is use any other trigger from the plethora of what Amazon gives us. We can see all the services here, but you can use it as a trigger, the S3 update, or pushing an IoT button, CLI task. A lot of people use the code pipeline for DevOps. So it's really nice to have all these triggers wired into the functions. The common uses that we see for the serverless architecture are mainly mobile functionalities backend, also IoT backend. We see a lot of bots and chatbots using that, which makes a lot of sense, especially in the scalability part. Schedule tasks, everything that is high CPU utilization on demand, file or imaging processing, everything that is distributed computing, fuzzers, machine learning. If you need to crack a password, this is probably the right way. And Alexa skills that use this as backend. So serverless is great, right? What else could we ask for? So how about security, for example? As I told you, a lot of developers, and we see it now also in people who are doing auditing, we show them the problems in the code and they say, this is not a problem because this is serverless. This is a function that goes to the cloud. And when we ask why is it safe? This is the explanations we get. And it's true, in a way. So the Lambda security advantages are mainly that it is running in its own environment. Okay, when running in the own environment, you have the potential damage is very limited. What we like to call sometimes sandboxed. So here, in a way as well, it is sandboxed. The second thing is that the environment is disposed after run. This means that there is no stored, no persistent damage. Even if there is some sort of micro damage, it will be vanished after 60, 100, 200 milliseconds. A lot of people think that combining these two together make every vulnerability obsolete. So, challenge accepted. We decided to check this this way of using known vulnerabilities just because it's serverless, and we decided to try and exploit a simple code injection in Lambda function that everyone thinks that it cannot do anything serious because, as I said, it's sandboxed and it's going to live for 60 milliseconds. We decided to create something that will be code persistent. I mean, we cannot really run something outside of code, but we wanted to change the code, to have the code itself hold the vulnerability, and make it even viral if possible. The link below by Rich Jones, you should read it probably. He has a lot of other challenges up for grabs in the serverless architecture. So let me explain our playground before we start the demos. It's really easy. It obviously runs on AWS Lambda. You have a very small app with 3 functions. One function is the main that is parsing input from the URL and calling either cars or users. If any of you is a UI person, I'm sorry. So this is how it looks like. I said I'm sorry. You can see that in the URL part, we call either cars or users. This is the part of the main function. This is the part of the cars or users. And the number here is just the number of car or user. This is as simple as it gets. Here's an example of users. This is user number 1, and this is how it looks like. So this is the playground. Let's see how it works. Okay, changing user to user 2. This is user 2. Changing cars. Cars 1. Okay. So let's discuss code injection. What is code injection? Usually I'm taking definitions from OWASP because they're doing really good jobs in definitions. So code injection is an injection of code that is then interpreted or executed by the application. As simple as that. And this is what we wanted to put in our code. So we made sure that our code is vulnerable to code injection. Anyone can see it? No. So this is the code. The code of main just parses the URL, takes the resource and the number, concatenates it together, and then uses eval. Most of you should cringe right now, and it makes perfect sense. Most of you also know that this is extremely common out there. This is something we see every day. This is what's happening outside as we speak. Evals everywhere. So it's okay you cringed, but this is life. So this is our code injection. It's on purpose. Now let's start playing. So we have a very, very short-lived instance when we run it. We wanted to see if there's anything interesting we can get out of this extremely short, and again, extremely short means milliseconds. Extremely short instance. So we went to documentation, and documentation said, yes, there is something interesting. There is a parameter called lambda task root. It tells you in the container what is the path, the exact path of where your functions sit, the actual source. And that's nice. I mean, I guess it's useful. So we wanted to know what path is it, and we used the code injection. You can see on top is the decoded URL, and in the bottom is the encoded one. So we used it as a payload to get the process and to get out of it the lambda task root. So let's see what we got. Okay. So that was simple. We managed to get the path. Actually, it wasn't that surprising because this is the default path when you're deploying new functions. But still, it's good to validate that this actually works. So this got us thinking. We can get the path. What if we want to get the actual code? The code may be interesting. We want to get the entire code of all the functions that are in this path. So this is actually exfiltration of the code, although as I said, it's very short-lived when it runs. Also, you're exposed only to one specific function usually. maybe we can use it to get all the code out of this path. So we have our container. We know that under the path var task, we have our three functions. What if we could use our own container or a hacker container to somehow copy it for future reference, let's say. And actually it worked pretty well. So we managed to tar the entire thing and send it to our... So this is the container of the hacker. You saw it's empty. We're running the payload at the moment successfully. Now refreshing the hacker container, and here it is, main tar. Everything just, all the code, you can get the index. And this is the actual source code that you can get. You can see the first yay that we managed to get out of it, because it exposes the actual API key of the AWS Lambda. You can lower your cameras, we already changed it. I saw that. Good thinking. We already changed it. But yeah, that was kind of too easy. But that's nice. So you can do that. What else can be done? This was fun, but it's not enough. So we went back to documentation and we saw that AWS Lambda really wants to help you. So including the functions that you created and deployed, you have the full spectrum of AWS SDK and AWS CLI, which is excellent. This is really excellent. You have the ability to list functions and to deploy new ones, to update existing, and everything can be invoked by code. This is really, really powerful. So this, I'm sure I'm hearing your voice in your head now saying, I'm sure it needs authorization, authentication, anythingation. No, it doesn't. Actually, it kind of needs authentication, but while you run your own function, you already got it. So running your own function, vulnerable function, you can basically run anything you want. So this is fun. So we decided to change some source code after we got it. Let's update all the Lambda functions that we can find in a specific path. So iterating between all the functions. Well, in our example, we have only 3 functions. In real life, it can be thousands. It can be even functions of other applications that are being used. So you can change a lot of things in this way. So iterating and using update function code that is on our malicious container. Just bringing it in and updating code. Let's see it happen. So this is our clean cars, painting it successfully, refreshing, and now after the refreshment, both cars and main have this code, although we only attacked cars. So obviously users is also tainted at the moment. So what we actually did here, we can see the code, we can see where you saw it in the demo, and this is just what we added, just the string, extremely smart hacked by string. So this is pretty great because we actually managed to get persistent infection. Although the function will run and then it will die, if I run the same function later, tomorrow, in a month, it will still be infected. But let's say it's not enough because it's only a one-time infection. If someone is going to clean the function or update it or something, it will stay clean. So not good enough. Here we can see that we added a reset function. The reset function cleans cars. It's restored. And then now we can see that cars is clean, while main is still tainted. So we decided to push even further the persistency and try to do some cross-contamination between them. So actually this jump is kind of logic and simple. Each infected function makes sure that all other functions are still infected. If it's not, infect them again. This is an actual viral infection. So we create cross-contamination. To make the idea simpler, if we attack users and run it, users attack main and cars. If we clean main and users, cars stays infected, and when it runs, it will infect main and users. And the demo again. So we infected users successfully. Now we can see that nothing happened to car and main. But now if we call users, car is infected. If we call cars, then we see that now both cars and main is infected. Resetting only main and users and leaving cars infected is only good until someone calls cars. When cars is called, we have again cross-contamination. Here you can see it. So it was kind of great because we actually managed to create this persistent code contamination we wanted in an environment that is by definition non-persistent. And this was really nice. We actually did some more plays and managed to do some heavy-duty remote code execution, but obviously you can understand that if this was possible, probably we can escalate it to things that are much more interesting than cars and users. So a few more words about AWS Lambda security. I want to talk about two important terms in it. There is the execution role and VPC. Execution role is actually what the function is allowed to do. While VPC, virtual private cloud, it means which virtual private cloud it belongs to, which means who or where can it send the information from inside this VPC. So let's talk about execution role first. We can look at Claudia.js. I actually didn't know it well before, but had a chance to play with it. It's really nice. It helps to deploy Node.js projects to Lambda pretty easily. And if you go to the documentation, you can see that Claudia asks you for full access. You can see the AWS Lambda full access is required for a Claudia deployment. It happens all over the industry in a lot of places, including Amazon own examples in GitHub. So this is from Amazon AWS Serverless CRUD sample. This is the boilerplate for many projects. All these projects use the same code. You can see that it's actually a prerequisite. Create an IAM role called Lambda role and assign it AWS Lambda full access. So by default and by recommendation of Amazon, please create your function as vulnerable as possible, actually. Please. Let's talk about the VPC. VPC is Virtual Private Cloud. By default, it starts with no VPC at all. The thing is that it opens outbound traffic. Just to remind you, the first demo we had was exfiltrating the source code. This would not be possible if VPN was set correctly. So the default is no VPC. We talked to Amazon about it. They said it's fine. We showed them the demos. We explained everything. They still believed it's fine. The only thing that they thought they should change is the example in GitHub, which they didn't do yet. I'm actually checking every now and then. It's been months now since we talked to them. It did not change yet. So this is Amazon. Let's talk about the... Wow, this is really bad colors. Okay, so I'll walk you through it. So we're comparing Lambda to Google Cloud and to Azure. Talking about access code via code injection, it's the same with all three of them. Downloading code to a hacker server. AWS Lambda we managed because there was no VPC. In Google, there is some sort of firewall block, but it's just using ports. It doesn't really care about IP, which we find a bit weird, but there's probably a good reason for that. Microsoft, again, there is the default is really open, but it can be blocked by network rules. Modify the function code. So we saw that we managed to do it in AWS Lambda. Google, they are not so keen to give you all the SDK by default, so no. In Microsoft, it's complicated. It depends on settings. We didn't go very deep there. Modification of code. We talked about permissions, so absolutely no problem with AWS Lambda. Not possible in Google yet. Again, setting stuff in Microsoft. And our viral injection, we already managed to do it in AWS Lambda, working on the rest, so maybe soon. I'll keep you posted. Okay, so approaching the end, key takeaways and actions. Yes, it is serverless, but there are at least two servers that can be attacked in the serverless architecture. One of them is hosting the container. The second is hosting the source code. Containers should not contain unnecessary sensitive data. I know it sounds really obvious. It should not. VPC must be defined. If you take the default VPC off, it's a problem. So, and there's no reason for it to be off. So there's just no actual use case that that it's needed to be off. The container is already authenticated, as we said. So you need to know that if a hacker has access to some sort of vulnerability in your function, he owns everything. He has all the authentication he needs. He needs nothing else. And obviously, the AWS SDK is really a nice gift for that hacker. So again, use least privilege role. This is right for everything, not only serverless. The AWS Lambda basic execution role needs to be fine-grained and not be all-inclusive with the top permissions. And it's always good to check the quality of the code eventually, especially in serverless computing. if we started by people who are not checking their code because it's serverless, now we can tell them, especially because it's serverless, you need to make sure you have no vulnerabilities. And that's it. Any questions?
Just a reminder, if you have any questions, if you can raise your hand really high so I can bring the mic really high so I can see you, because it's hard to see over people.
Also, if someone does not like to ask questions in a big room full of people, you can contact me. I promise to answer.
Hey, so I have a two-parter, if you'll allow it. The first question is, obviously, the SDK, if you get access to that through an eval, that's crazy. You could potentially do anything. But do you need an eval? Is that pretty much a prerequisite for any type of viral infection? Or
what we try to show here is the reason you need to actually treat vulnerabilities in code. Of course, we took the most simple one, just as a POC. It's really important to understand that if it can be used outside of the scope of functions, it can be used in a function on a serverless as well. This was the point that we tried to prove. So the evil was planted on purpose. If you have any other vulnerability in the code, we can probably find a way to use it. So the evil was an example.
Oh, and so the second part here is, if you extend the lifetime of, if you add code to an eval or something, right, you got something that's processing, if you're increasing the length of time of the average, Lambda operation, is that going to be caught by Lambda naturally? Is it going to just say, oh, I'm alive for too long, I'm going to terminate?
Okay, so this returns me to the reason why some organizations are not moving to serverless, and this is monitoring. It's really hard at the moment to monitor all your activity. It happens in many places at the same time, different containers, sometimes different places on the globe. It's really hard to monitor. I know Amazon is working on it, so I would like to say that there is a possibility to monitor that, but I'm not 100% sure. Also, I think you'll have a bit of a problem to know in advance how long you want this specific function to work for you, unless you have some sort of clue in the general terms. Make sense? Okay.
Does anyone else have a question?
So the SDK provides a way to access the source code, or what is that? Is that like intended part of it?
The SDK is something that Amazon gives you. It's a bunch. It's like a toolbox. It's a toolbox of functions that enables you to work with with all your functions. Sometimes it's only to list them. Sometimes it's to update them, to deploy them, change the code, even delete. So this is something that Amazon lets you do, hoping that you're doing it with the owner's hat, obviously.
Yeah, just real quick question to check my understanding. So the permission issue where they're being granted too many permissions for the function, would that, if you had the lower permissions, the correct permissions, that would restrict being able to modify other functions, exactly, but it wouldn't restrict the exfiltration, right?
Exactly. Actually, there is a very nice fine grain level that you can get to. You can restrict what you can change, if you can touch other functions, when you can do it, under which terms, specific methods or specific functions in these terms that can do specific things. Obviously, the easiest way is to say, okay, everyone can do everything, and no debugging needed from now on.
Right. Great. Thanks.
Hi. In your example, you showed that the function has access to an environmental variable that showed what the source code was being read from. I was hoping you could elaborate on maybe some of the other variables that you might have access to in the environment.
The other variables are not something that we went for, but other variables are, for example, on which continent the container is, what time was the last time that the specific function was deployed, more like metadata, let's say. I think that the path one was the most interesting in our eyes.
Anyone else have a question? One last call.
Okay.
All right. Thank you so much, Erez.